solve application problems using systems of equations, we will follow the same 4 basic steps that we have used for solving previous types of applications. First, we will define 2 variables to represent the unknowns in our word problem. Then, we can translate the problem into a system of 2 equations. Next, we will solve the system using a method such as substitution or elimination. And then finally, we can use the solution of the system to answer the questions posed in the word problem. It's important to remember to label the answers with the appropriate units as well. One of the most common applications of systems is a type of problem involving a mixture or combination of 2 different items. So let's look at some examples of these mixture problems. In a recent basketball game, the Patriots scored 56 points. Of those, 8 were from free throws. The remaining 48 points were a result of 21 made baskets consisting of 2-point and 3-point shots. How many baskets of each type were made? To organize the information in a mixture problem, it's often helpful to use a table. And we're going to label the columns of our table with the types of items that are being mixed or combined together. In this case, we don't need to worry about the free throws since we already know that there were 8 of those. What we are combining here are a certain number of 2-point baskets and a certain number of 3-point baskets. And then we have a total sort of mixture of these 2 types of baskets that results in the end. And what information do we have about these baskets? Well, first we have some information about the number of baskets that were made in total. And we also have information about the number of points scored in total using those baskets. Now let's begin to fill in the other parts of the table. We can use this table to define our variables. Since we don't know the number of 2-point baskets, we'll let that equal x. And since we don't know the number of 3-point baskets, we'll let that equal y. But we do know that the total number of baskets of 2-pointers and 3-pointers made altogether was 21. Now let's consider the number of points scored with these baskets. If x 2-point baskets were made, each one being worth 2 points, the number of points scored on those baskets then is 2x. And similarly, the number of points scored on the 3-point baskets would be 3y. The total number of points scored on 2-point baskets and 3-point baskets together is given as 48. Now this table helps us to generate a system of equations that represents the problem. First, considering the number of baskets, we see the equation x plus y equals 21. And then considering the number of points scored, we have the equation 2x plus 3y equals 48. Now once we solve this system using either substitution or elimination, we will find that x equals 15 and y equals 6. Therefore, the answer to the word problem is that 15 2-point baskets were scored and 6 3-point baskets were scored. Let's consider another example. A hiker wants to make 24 ounces of trail mix using raisins costing 15 cents per ounce and peanuts costing 36 cents per ounce. If the mixture will cost 29 cents per ounce, how much of each ingredient should be used? Again, let's label the columns of our table with the items that are being mixed. In this case, we have raisins and peanuts that are being mixed together to produce a mixture of trail mix. Now for the rows again, we will label those according to the information we have about these items that are being mixed. We first know something about the total weight in ounces of this mixture. And we also have information about the cost of the mixture. And that's obviously measured in dollars. To fill in the rest of the table, we can define R to represent the number of raisins, and P to represent the amount of peanuts, and the total weight of those 2 items is 24 ounces. We have R ounces of raisins, and the cost is 15 cents per ounce. Then 0.15 R represents the cost of those raisins. Similarly, 0.36 P represents the cost of the peanuts. We have to be a little bit careful with representing the cost of the trail mix. We're not given a total cost here. We're given a cost of 29 cents per ounce, so we need to multiply 29 cents times 24 ounces to get the total cost of the trail mix. Now we can write our system of equations. We have R plus P equals 24, and 0.15 R plus 0.36 P equals 0.29 times 24, which is $6.96. Again, we can solve the system by any method we choose, substitution or elimination. We would find that R equals 8 and P equals 16. So we know that the hiker needs 8 ounces of raisins and 16 ounces of peanuts. One final example. For a science project, a student needs 300 milliliters of a 48% acid solution. How much 60% acid solution and how much 20% acid solution should be mixed together to obtain the desired mixture? Again, let's organize the information with a table. The columns will represent the types of items in the mixture. So we have a 60% acid solution that is being mixed with a 20% acid solution in order to create a 48% acid solution. Now, what information do we have about these items? Well, first we have some information about the total volume of the solution. That's measured in milliliters. We also have some information about the amount of acid in the solution, which would be an amount of milliliters as well. So we'll let the amount of 60% acid solution be X, and the amount of 20% acid solution be Y. The total number of milliliters we have is 300 for the entire mixture. If we have X milliliters of 60% acid solution, then the amount of acid in that portion is 0.6 times X. And similarly, the amount of acid in the second portion of our mixture is 0.2 times Y. Finally, the total amount of acid in the entire mixture is 48% of 300. Now let's write our system of equations. The first equation would be X plus Y equals 300. The second equation, 0.6X plus 0.2Y equals 0.48 times 300, which is 144. Again, if we solve that system, we'll find that X equals 210 and Y equals 90. So to answer the question in the word problem, the student will need 210 milliliters of 60% acid solution and 90 milliliters of 20% acid solution.